Okay, what we're going to talk about is how to find critical points of a function. Now, critical points, by definition, are, you can also hear them called critical numbers. Right? There's a slight difference between them. Critical numbers are simply the locations of where f prime equals 0 and where f prime does not exist. Right? On a certain interval of the function. Critical points are actually the actual points of those values on the function itself. Okay, so where those points are located. But critical numbers and critical points are by definition where f prime equals 0 or where f prime does not exist. So when you're asked to find critical numbers, that's all you're asked to do. You're simply asked to find where does f prime, where's the derivative, where do the slopes equal 0, where the horizontal tangent line is located, whatever you want to call it, that's what you're asked to find. Or where f prime doesn't exist. Okay, so in any case, that's what you're asked to do. So in this problem, we're asked to find the critical numbers. So we're going to find where g prime essentially equals 0 or where g prime does not exist. Well, obviously, if that's what we're asked to do, how are we going to do it? Well, I guess we're going to find g prime. In order to do this, we're going to use a chain rule. So we have to take the derivative of the outside, which is 3x plus 1 squared times the derivative of the inside function, which is equal to 1. And what we have is 3x plus 1, that quantity squared, equals 0. That derivative does not ever not exist because it is a polynomial and it will exist everywhere. So let's find this horizontal tangent. This is equal to 0. So I'm going to solve for x now. Solve for x. I apologize for my penmanship. All right, from here we divide by 3. We have x plus 1 squared equals 0. We're going to take the square root of 0, which is 0. So we have x plus 1 equals 0, and x equals negative 1. So at x equaling negative 1, that is the critical point. If you looked at this graph, this actually is a cubic function shifted over to the left 1. And so we have this graph right here. And we know why right there we have a horizontal tangent there. So we can identify with the graph. Well, let's try one more because that was pretty easy. Let's try another one. All right, maybe this one be a little bit harder. Oh, there we go. Extend out this page. All right, let's try this one. We're asked to also find the critical point. So once again, we're going to find where y prime equals 0 or when y prime does not exist. That's how you find critical numbers. All right, so we're finding the critical numbers here in this problem. Okay, so we find y prime first, and we take 3 times, all right, derivative of this would be 2/3 x minus 2. Subtract 1, and we get negative 1/3 times the derivative of the inside, which is 1. And now we're going to take the derivative of negative 2x, which would be negative 2, and the derivative 4 is 0. All right, from here we're going to simplify it, and this will cancel out. So we're left with 2 over x minus 2 to 1/3 minus 2. Well, first off, we'll set this equal to 0. Find out where this doesn't exist. From here, I'm going to add 2 to the side. We have 2 over cube root of x minus 2 to there. And do my little algebra math magic. We're going to just flip them, all right, or cross multiply, whatever you want to call it. But we can take this, and we have 1 equals x minus 2 to the 1/3. Okay, find out how I did that. You can go 1/2 equals this right here, x minus 2 to the 1/3, 2, multiply 2 over there, so we get 1, and if you don't like the 1 right there, put the 1 right there. Okay, so we have that. Now we're going to take the cube both sides, so we have 1 equals x minus 2. We're going to add 2 to both sides, add 2 to both sides, and we get x equaling 3. So there we have right now is a critical number at 3. Well, once again, that is where this right here equals 0, but we're not done yet because that's when this equaled 0. But we also have to find where y prime doesn't exist. So I'm going to find where y prime doesn't exist, and I'm going to move this over here. Get some room, and make this in red. Y prime doesn't exist when the denominator all right, equals 0. So this is y prime. So basically, we're going to take this denominator right here, x minus 2, 1/3, and set that equal to 0. That's when it would not exist. Correct? That's when the rational function wouldn't exist. So we can obviously see this right here when x equals 2 is our other point of our critical value. Now I'm curious, is I want to take this and I'm going to actually graph that. So once you have your graph utility and graph that, I'm going to punch that in here because I always like to graph my functions so I can see them visually. So I'm going to just see what this one looks like. We're going to have x minus 2. We're going to take that to the 2/3 power. And we're going to say minus 2x. And we're going to go plus 4. When we graph that, we can see we have a function looks like that. Now my viewing window, if I go zoom 6, you can go back to a normal viewing window. And we have our graph that looks something like so now. There we go. All right. Moving this over here. Now looking at this graph, we can now identify, all right, well, we see that now that there is looks like it appears to be a cusp or something right here at x equaling 2. And that is exactly, if you recall, where we identified our derivative to not exist. At x equaling 2, where there would be a cusp. So that matches up. We then identified a horizontal tangent at 3. And right here, if you notice, there is a horizontal tangent right there at x equaling 3. F prime equals 3, or is 0 at x equals 3. And f prime doesn't exist at x equaling 2. So once we did our analysis and identify where it equals 0, f prime or y prime equals 0, and where it doesn't exist, we can identify, all right, should use that because that is not f. Doing y prime, in this case. All right, we have that. All right, so that is how you find critical values. That is how you find critical points in critical numbers. All right, you set the derivative of the function or equation equal to 0, or find out where it doesn't exist. I hope that helps you with your critical questions in the future. Have a great day.